All right, welcome everybody. Let's do this. Remote learning lesson number 1, trigonometry lesson number 1. So, the name of the class is called Algebra 2 Trig, and this is the first day we're actually going to do trigonometry. So, let's do it. If you have this page, great. If you couldn't print it, don't worry about it. I'll let you know which parts to copy down. So, for the first part, let's just go to this part over here and let me zoom in my camera. Okay, perfect. So this lesson was supposed to be a hands-on activity. That would have been really fun. So medium smiley face, right? But no worries, we got this. All right, next part. So I want you to pretend that you have this paper plate model over here. And what will it actually look like in physical space? It'll look something like this. This is the paper plate model. So notice that we have some sort of circle and we have the lines here, and I'll explain what that means. Okay, so I want you to pretend that you have it in front of you, LOL. Okay, so step number 1. Let's present the paper plate model. Okay, so we already have that. Step 2, let's think about a circle. Okay, how many degrees are there within a circle? Okay, so think about it. You know it. We don't know it. You should have 360 degrees inside of a circle. So for one full rotation. Okay, let's go to the next part. Now, within the circle, let's break the 360 degrees into 4 parts. And we're going to call it the 4 corners. So notice that if you have 360 degrees, and we're going to break it into 4 parts, we're going to divide. And how many times does 4 go into 360? Take your time, do the math, but it should be 90. So the idea is the same way where we have the paper plate model, and the starting point is right over here on the right side, we're going to break this into 4 parts. So the idea is that this will be 0 degrees. This will be 90 degrees. This will be, well, what's 90 plus 90? This is 180 degrees. And then this will have to be, what's 180 plus 90? This has to be 270 degrees. And then what's 270 plus another 90? This should be back to where we started at 360 degrees. So within trigonometry, we're going to start here. We're going to start from 0 and then go all the way around to 360. And we're going to make this counterclockwise rotation. Okay? And I'll talk about what that means later on. Okay, so that was this part over here. What's the next part? Let's take a look. Here, we broke it down into 4 corners. Okay? What is step number 4? Now, let's start at 0 degrees, and we're going to count by 15 degrees all the way to 360 degrees. And we're going to label this on our paper plate model. So let's imagine you have this in front of you, and we're going to count all the way up to 360 degrees, and we're going to count by 15. And notice that I don't have a protractor, so the measurements are not going to be perfect. But the idea is, let's count by 15, okay? So here, this is 0 degrees, right? So 15 degrees of rotation should be somewhere over here. This is 15 degrees, give or take. Then what's 15 plus 15? This should be, actually, I'm sorry, I kind of messed this up. This shouldn't be 15. 15 should be like right here. This is 15 degrees. This will be like 30 degrees. This will be 45 degrees. Then this will be 60 degrees. And this will be 75 degrees. And the idea is I'm going to go all the way around. If you want, you could just fast forward it. If you want to see me do it, go ahead. Okay, so this is 75. The next one has to be, this is 105. This has to be 120. Okay, this is 135. This is 150. This is 165. This is 180. Okay. What's the next one? This has to be, this is 195, 210, 225, 240, 255, 270. Okay, so then this one should be, give or take, this should be 285, 300, 315, 330, 345, and then back up to 360. You see, the idea is I was going to give you a protractor, and you would have done it yourself, and you would have gone around 15 degrees all the way around. Okay, so here we have 0 all the way to 360, and we went up every 15. Okay, what is the next thing we're going to do from here? So we did step 4. Step number 5. Now, we're going to create something called the height function. Oops, sorry. We're going to create something called the height function. And what will the height function do? Okay, the height function will take a point and measure the distance from the point to the x-axis. Okay, so pause, timeout. What on earth are you talking about, Mr. G? Let's take an example. You see what it's saying? It's saying take any point and measure the distance from the point to the x-axis. So let's take a look over here. Imagine if I had these points over here. I had A, B, C, and D, and they're over here. Now, if this is the x-axis, what is the definition asking from us? You take the point, from the point, we're going to take the point to the x-axis. And what are we going to do? We're going to measure it. So the measurement from A, notice that the distance from A to the x-axis, this is just 1 centimeter long. So this is just going to say, 1 centimeter. Whatever the distance is from here to here, we put that over here. Whatever the distance is from here to here, we have it here, and whatever this is here. Imagine if I had a point, letter E over here, the height of E is just from here to here. Okay, it's just this vertical distance. And why will that be important? Because what I want us to do, and for height, I want you to think up and down. What we're gonna do is, we're going to find the height of every degree around this circle, okay? And that's what I wanted you to do in class. So let's say if we had 15 degrees over here. How do you find the height of 15 degrees? Well, I go to 15, and let me use like a pencil. The idea is I'm gonna find the height from here to here. So what I do is I just take my ruler over here, and notice, give or take, what is the height? It's about 2 centimeters. Okay, and actually, my bad. Let me zoom in a little bit. Because here, notice that this is the, my bad. This is the x-axis over here. So we need to find the distance from here to here. So what will it look like? We will just do the distance from here to here, give or take, it'll be 2 centimeters. And that's what we're gonna do. That's why we have this diagram over here. Now what I want you to do is, because you physically can't do this yourself, I'm going to do it for you. But the idea is, you could fast forward as I do it, but what I want you to do is, if you have this printed, great. If you don't have it printed, please write this down, and I want you to copy this into your notes. Notice that this column over here is the rotation, so 0, 15, 30, 45, 60. And over here will be the height of what we actually calculate. So let's go to the next part. So after 15, we have to do 30. So let's take a look over here. So I go back to my diagram over here. Notice that what was the height of 15? It was 2 centimeters. If you think about the height for 30, will the height for 30 be larger or smaller than 15? It looks like it's going to be larger. And notice that from here to here, give or take, it's about 3 centimeters. Okay? Now what I'm going to do is I'm going to do this for you. And I actually already did it. So what I'm going to do is I'm just going to copy down the numbers. So let's just take a look how it'll happen. So here, whoops, I am so sorry. I messed up. I am so sorry. Look, this, sorry. This is 15 degrees is here. This is 2 centimeters. Let me get this here. Sorry. This is 2 centimeters. What about 30? We just did it. That was 3 centimeters. I didn't do it for 15. So the idea for 15, I'm sorry, for 0, my bad class. The idea, what's the height of 0? What's the distance from this point to the x-axis? It'll just be 0 centimeters. Because, like, what is the height from here to here? It's nothing. But what if we rotate 15 degrees? What's this height? 2 centimeters. What's this height? 3 centimeters. What's this height? Let's say it's, I don't know, 4 centimeters. What's this height? Let's say 5 centimeters. And how do I know it's increasing? Because the distance from here to here is bigger than here to here, here to here, here to here. And then what about here? Do you think the distance will be larger than 5? Or, let me zoom out a little bit. Will this distance be larger than 5 or smaller than 5? So let's say it'll still be larger. So this is 6 centimeters. Okay, what about here to here? This will be 7 centimeters. But now what happens when we start going to the next one at 105? Notice the distance from here to here is less than the distance from here to here. So notice how the height, if you could draw the straight lines, they are getting smaller and smaller and smaller until it goes back down to 0. So here, let's take a look. Yeah, this is very unfortunate. We can't do this in person. But let's take a look. You see, notice, let's say if this is 7 centimeters. When I go to 105, this will have to be less than 7. So this will be 6 centimeters if I actually take out the ruler and measure it. Okay, because that's what I wanted you to do. I want you to measure these straight lines. So notice how the distance, the height, is getting lower. So this is 6 centimeters. Then from at 120, it's 5 centimeters. Then this should be 4 centimeters. Then let's say 3 centimeters. Then here, 2 centimeters. Actually, no. This should be, yeah, this is 2 centimeters. And then what about at 180? Notice what's the height of 180? This should be 0 centimeters. Okay? And the same thing is going to happen here. That if I go from here to here, from 195, if I take my ruler, it should be about 2 centimeters from here. So then I'm just going to write 2 centimeters. So if you want, you could just fast forward it. But I'll just do it here. So 2 centimeters, 3 centimeters, 4, 6. This should be at 7. Because notice that what's happening from the height, you're taking the distance from here to here. Notice that the distance from here to here has to be the same as here to here. So 7, 6, 5, 4, 3, 2, and then this should be 0 centimeters. Okay, because the idea is what's happening to the height as you go back when you go from 270 to 0. I'm sorry. 270 to 360, notice that the height, the straight line from here to here, it's getting smaller. Okay? And then we go back to this. Okay? So I'm very sorry if that was sloppy, but this is the best of what I'm trying to do right now. It would have been much better in person. Okay? So that was the height function. So we did this part here. And if you want to see it so you can copy it, these should be the numbers. Okay, now what is the final thing we're going to do for this part of the lesson? All we need to do is let's graph the points to see what the visual will have to, what visual we will have created. Oh God, that sounds awful. Let's graph the points to see what visual will be made. All right, will be made. I'm sounding like Yoda over here. Okay, let's go to the next page over here, and the idea is whatever points you have here, let's graph it over here. Okay, and for sure you can do this. Okay, so what I want you to do is, if I have 0, 0, that's going to be the first point. So 0, 0. Notice that this will be the x-axis and this will be the y-axis. Here, this is your x-axis with the degree of rotation, and here this will be your y-axis. If you want, and if you can't print, then please copy this down into your notes with these measurements, right? You see how it's from 0 to 360? And notice what's in between. Like this is 0, so this has to be 15, 30, 45, 60. This should be 75, 90. This should be 105, 120, and so on, right? So you can do this. Yeah, let's do it together. 150, what's the next one? 165, 180, 195, 210, 225, 240. There should be 255, 285, 315, 345. Okay? So what I want you to do is, let's put the first point. The first point was 0, 0. What's the next point? It should be 15 and 2. So where is 15 and 2? Okay, so I go to 15 degrees, and then 2 centimeters should be right over here. Okay, and then let's do the next one. This should be 30 degrees, 3 centimeters. 45 degrees, 4 centimeters. Okay, what I want you to do is put every single point onto this graph, and let's see what the graph will look like. So let's take a look. It should look something like this. Okay. So this was this. At 60, it was 5, 6, 7, like this. Okay, so the points should look like this so far. And then what happens to the points? They go back down. So then at 105, it was here. At 120, it was here. At 135, what is it? It's 4 centimeters. Okay, so at 135, it's 4. At 150, it should be 3, then 2, then 0. So notice that your graph kind of looks like this. It goes up, 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 down, up, and then it starts going down like this. And notice that the curves are going to be smooth. So you should have some smooth. It's not like a straight line from here to here. It's going to be smooth, like a parabolic, right? Okay. And then what has to happen next? Literally the same thing happens again. Notice from 180, let's see what happens at 195. It's here, 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 here. Anyway, this should be a little more up. It should look something like this. Okay. It's not perfect, but the idea is as long as you have this type of curve, then you're okay. Okay. And that's for this part of the lesson. It would have been much better to do in person, but here it is. For the next part, I'll do it later today, but for this part over here, these questions, I'll have it in a separate video. Okay, I hope you enjoyed it. I'll see you.